Dear friends, welcome to Infos. Welcome to our regular show, Oil and Gas Training Series. Now we are going on gas processing. This video is gas processing part 10, dehydration part 4. In this video we are discussing about P&ID and control system using in a dehydration system. Welcome to this video. I have uploaded a P&ID, a typical sample P&ID of absorber and stripper. So entire dehydration system. So just to have a look, in this video we are concentrating on how to read a P&ID and important notations, symbols, various control systems using process variables using here. So just we are discussing about that one. Definitely we discussed this one in our previous classes, in previous videos. But in P&ID, that once you see this one in the P&ID, you will get a better understanding on that one. So just to have a look that one. So quickly I will rewind the process. What is dehydration? Dehydration is a removal of moisture from natural gas using glycol as the solvent. So here the first process is the absorber. You can see that one. This is absorber. I will just do a little bit zooming. See, this is the absorber. Okay, absorber in the bottom. This is the absorber. So the feed is a natural gas. In absorber, glycol is contact with natural gas and remove the moisture into the glycol or dissolve the moisture into glycol. So this is this one. So the feed gas is coming from here. Feed gas is coming from here. See the feed gas. Feed gas is entering to this one. The bottom part is the inlet knockout drum. Sometimes this one is the integral part. Sometimes this will be a separate knockout drum. So here it is a inlet knockout drum and is a integral part. Doesn't matter. So see what are the items here? See, look at that one. It is entering here, and whatever the liquids, any contaminants, any other liquid particle is there, moisture, free water is available. It will settle here in this one. In this is a inlet knockout drum, and see it is entering through a inlet plate. You can say inlet plate. So reduce the velocity of the change the velocity, reduce the velocity of the gas, change the direction, and entering through a inlet deflector plate. So it will giving a swilling action, and free water, whatever the free moisture and water available, it will settle here, and then it will pass through a demister pad. This is the another important internal demister pad. So in the demister pad, it is passing. All liquid will collect here. Whatever the liquids particle, heavy liquid particle is there, it will collect here. So a pre-separation is taking place that will affect the performance of the absorber. So these two internals are very, very important of the dehydration process. Then it will enter here. See inside here it is a chimney is there. So whatever the gas is entering here, see it will go and passing through the direction like this. In the there is a deflector plate is there, a diversion plate is there, that will collect here, changing, and then it is going here like this. Unfortunately, this scrubber, this absorber is showing packing column, not our regular bubble cap column. I will try to show that one in later part of the video. So it will anyhow trace are here will randomly collected, and it is a packed column system. Please review my previous video on packed column. That link I will add here. So then the gas is going up, and in the packing, the same time the glycol is coming here in the top of the packing and spraying here using a nozzle. Here it is spraying and distributing equally through the packing. and in this packing it will contact each other, and moisture is absorbing, dissolving in the glycol, and free gas is going up and passing through another demister pad here to remove further liquid particle and glycol particle, moisture particle, etc., collecting here, and it is going releasing from the top of the vessel absorber and going to a heat exchanger here to become making cool, making slightly, actually it is heating, getting heating because it is cooling the glycol here. Our important aim is to reduce the temperature of the glycol that we have discussed in our previous class. Glycol temperature should be just above than gas temperature. So that will maintain here, and it will going to, still it is the gas is going to exit absorber, that is the outlet knockout drum, that you can say outlet knockout drum. It will also, inlet deflector plate is there. See, it is a different type of inlet deflector plate. The same thing, it is collecting the liquid particle, hydrocarbon and glycol particle here. It is collecting here, then through the demister pad it is going to the distribution line. So this is the process here. So in the gas line, in absorber. So we will just go through the important process variables controlling the performance of this one absorber. We can check it, that one. Just so whenever using this same video, you have to read this one in proper way. Each and every pinpoint you have to reading. Any doubt is there, you can ask me, I will answer it. So this one we have discussed, that one temperature or pressure indicator is there, and here it is the shutdown valve is there. In any case of the abnormality coming here, SDV will work as it, SDV will close it. These SDV logics are there. This diamond box is a SDV logic. So this is the three-way valve, solenoid valves are there, instrument air supply is there. All it is I have explained in detail in our one of the my video in P&ID. In that one P&ID maybe 1 or 2 videos are there. You can check that one. Detailed discussion we have conducted there, and so I don't want to discuss here that one in too much. So this is the all shutdown logics are there. See, all diamond is giving a individual shutdown logic, this one, and SDVs are there, limit switch is there, and it is entering to here, and in the bottom you can see what are the level gauge is, level glass is there, then level control, LIT is there, level indicator transmitter is there, and it is going to, they see the shutdown logic, and it will go to somewhere in the level control, this level. And when the what is the reason for that one? In case the moisture level is increasing, it will carry over with the gas. So try to avoid the level above a particular percentage in the level. See, that's why it is a level control system is there. See, from where it is taking LG, level glass, and LIT, level indicator transmitter, then it is a LIC, level indicator controller, and there is also high and low alarms are there out of that one. Then it is going to LV. See, the LV is there. See, LV, this is the level control valve. LV is there. Just outside above that one is a solenoid valve is there. Solenoid valve, there is a shutdown logic is also there. Everything is there. Whenever the level is increasing, it will trip. Whenever the level is decreasing, no level is also, it will trip. Because if the no level is there, the gas will pass through the downstream equipment. That is not also possible. High pressure gas will pass through this downstream. So level should be maintained a minimum level to prevent the gas leak passing to downstream equipment and prevent the level going high with and carry over with the gas. These two conditions also to maintaining in this level control valve. That's why it is level alarm high and level alarm low. And this one LG, LIT, and LC and LCV. Also this valve will act at a failed to close valve. See, the FC, it is written here FC, that is a failed to close valve. So shutdown logic also working here, and this gas is this liquid is going to closed drain vessel. That's okay, clear. So we have discussed about gas inlet, gas outlet, and glycol is entering, and here in inlet dicotron, then moisture and free water is removing from here using level control system. And another one is the glycol is entering here. Glycol temperature always we are maintaining. See, the inlet glycol temperature is maintaining from where? Glycol is coming from here. See, this is coming from somewhere. This line coming from here. See, the inlet temperature before the heat exchanger. Then that is the shell side it is entering, and outside it is entering here. The outside temperature also. There is no control on this one. Control may be the temperature control may be in somewhere else. We can see that one whether it is available or not. So temperature also maintaining here. It is entering here through a NRV, and the isolation valve is also there. It is distributing here after absorbing or dissolving all the moisture particle. Glycol is settling here. See the chimney height in this area, in the downside of the chimney area, it is settling here. See, the glycol is rich glycol. You can see it is going out from this one. This is the glycol going out. See, glycol, it is going to condenser. Actually, it is going to regenerator, glycol regenerator. In this line, you can see level glass is there, LT is also there, LIC is also there, and LV is there. See, LT, LIC, LV. That is the level control system for the glycol, maintaining the level here. Should not increase the glycol level here above the particular level. If it is increasing, it will carry over with gas. So it should be maintained, well maintained. That's why the LG, LT and LIC and LV is also there. See, that's so that the level control is working perfectly here. And in the other side, see, LG is also there, LIT is there. It is going to the shutdown logic. What is the shutdown logic? High level of glycol inside the bottom of the absorber and low level of the glycol bottom of the absorber. These two safeguard systems are connected here in the level side. Yeah. So the level is well maintained here, and the safeguard system also there. It will lead a shutdown. In that shutdown logic is connected to here, and this SDV will work. Now, this not only this SDV, many other SDV will work. Any fail to open, fail to close valve is connected to this. Entire shutdown logic will work according to their logic. And here also PDT is there. What is that PDT? Differential pressure transmitter. Entire from the bottom to top. See, differential pressure transmitter should be 0. Means there should not be any pressure differences coming inside. That will create a choking inside the problem, inside the tower. So we can check a inlet deflector plate and demister pad and the chimney in the packing, and plus this demister pad. This all will cover that one, this safeguarding system. If the PDT is increasing, that is differential pressure is increasing above a particular point, say safely say that about 5 psi, that means it is in absorber inside there is a choking or foaming or whatever it is, differential pressure is increasing. So smooth performance is affecting and decreasing. So that we can find out and correcting properly. And another one is pressure transmitter is also there. See the pressure transmitter, P8 is there. This line is taking from the top level pressure transmitter, and it is connected to another logic, shutdown logic. That all logic is connected to our previously told SDVs. And the last safeguarding device, PSV, pressure safety valve, is also connected. In case the all safeguard system fail, that one is a mechanical system. We have discussed that one in our previous classes. That PSV is also connected to flyer or releasing your safe location. So these are the important concept. And glycol I have to discuss some more. And here also the liquid connection, I didn't discuss that one. See, here also the whatever the liquid is connecting here, it is the C joining back to the glycol system, including moisture. There is also a level control system is there, because liquid level including glycol cannot increase much, and it will carry over with gas, and we will make a huge loss of glycol. So that's why level is maintaining properly. Level control systems are there still, and level control system with connecting a shutdown logic. So this one. So that is also connecting here, and here SDV is also there. See, shutdown logic 1, 2, 2 shutdown logic is connected with, see, 3 a solenoid valve with instrument air supply and shutdown valve SDV and a fail to close valve. These are the important things. See, this is shutdown logic, this is shutdown logic, this is the three-way solenoid valve, this is instrument air supply, this is SDV, and this valve behavior is a fail to close. In case this instrument air supply close in any condition, this valve will go to close condition. It will close, fail to close. That is a FC valve. This is clear, that one. So these are the important. In another one is a very important one to discuss, that one. See, indicate the final temperature also measuring, final pressure also measuring, and another one is AIT, that is analyzer. What type of analyzer we have to keep here? The important one is a moisture analyzer. So the recommended practice, the recommended moisture level is always checking to see the performance of the absorber. In case of moisture not removing, maybe they can bypass this gas to back to absorber again. So this is AIT is analyzer indicator transmitter, and it is connected to a DCS, and it is there's a high moisture coming, there will be a alarm high. See, this AI is in the DCS and high alarm is there. If any of you are not very good in means less confident in P&ID, please review my previous video about P&ID, piping and instrumentation diagram, to understand this one properly. This is a basic fundamental, so just to go through it and understand it properly. Okay, so then I will go to another video that is clearly now absorption system is already understand that one. We have discussed about gas inlet, gas outlet, glycol inlet and glycol outlet, 2 inlet and outlet knockout drum. So next is rich glycol with moisture coming to the regenerator, and removal of moisture from glycol to make glycol purity about 99.9 or 98.9, at least 99. Then making lean glycol, removal of the moisture using reboiler, stripper, then going back to our absorber. So this point we will discuss in this P&ID. Look at that one. This is the, this area is see, stripper, this is the stripper area, we can call a stripper area. This is the stripper condenser in the top of that one, and this is the reboiler. Many companies are using different type of design, but in this company, this is the whatever I have available P&ID look like this one. So glycol is entering for preheating here. The preheating like glycol is cooling the water vapor outside. That also possible. So this is the water vapor going. So glycol is actually enter here. Glycol is enter in the top of the packing column. Here somewhere it is entering. Then in this packing it is covering that one. It will enter to in the reboiler. Reboiler, this is the reboiler coil. See, look at that one. This is the reboiler coil. Always the level is maintaining in this level. We have discussed the process in the previous classes. Here only showing the P&ID. So this level is always maintaining, and various temperature controls are there that I am coming to that point. And here there is a still column. There is a column level is maintaining the level is here. Whenever the overflow, that is a lean glycol is passing to the surge tank. That is the surge tank. Extra glycol level is maintaining here. That is, this is the lean glycol. That lean glycol is passing through various pumps and other things to see lean glycol. This lean glycol is going back to our absorber. So in this one, mainly we have to discuss about the temperature. Here reboiler is what is using reboiler in the previous class discussed. It is maintain the temperature of glycol around 125, around 115 degrees C. That temperature control systems are here. See the firing method is, that's not showing here. This is the coil. Maybe it is electric coil or firing, whatever it is. And this one, you see, temperature control is there, level control is there, see, LI is there, and it will connect it to a shutdown logic. See here, level switch is there, level switch, automatically it will trip the burner or this heater, whatever it is, either electrical or gas firing, whatever it is. And temperature also, see TT is connected here, see, is a thermocouple is there, or bimetallic, or resistance type, any type of a temperature sensor is here, see, temperature sensor, and TT, temperature transmitter, it is connected to shutdown logic, and DCS also we can see the temperature, and this is also connected by computer, it is somewhere else going to different location, to other drawing also, other location also it is going. And here also another one, see, it is 1 out of 2, two voting systems are there. See, another temperature indicator controllers are there. Why this one? This controller is connecting to this fuel flow control valve, FCV, or temperature control valve. That is also this one. This controller is connected, and it is high and low level alarms are there. And this, in the DCS there is a temperature indicator, and low level and high level alarms are there. So temperature of a reboiler is well maintained and controlled, and the level of the glycol should be maintained always above the coil, heating coil you can say, that also well maintained here. These two conditions are covering here, and safeguards, temperature and level safeguards are there here. Clear that one. Another one is, see the moisture, free water out and going back to, it is going to releasing to the atmosphere. And here also it is temperature, see, pressure also here in the reboiler, pressure also taking care, see, differential pressure transmitter, and PIC, it's a pressure controller, and PI is also there, and it is a F or PY, it's a pressure control valve, PV is there, and a fail to open valve is there. So if the pressure is also high in the reboiler, the valve, it will create a shutdown, and it will release the free water from here, and pressure safety valve is also there. So to read this one in proper way and understand each and every pinpoint here, and the temperature, both temperature in the condenser area to become maintained in this condenser area is maintaining, as we discussed in our last class, maintaining the temperature of exit water vapor around 102 or 103 degrees C to prevent the glycol loss here. If too much temperature increasing, that is glycol loss will be more, and temperature is become less than 100 degrees C at atmospheric pressure, then water will condense here. So water vapor will not release. So increasing reboiler load. So these are the temperature indicator. There is no controller showing here. So this way it is working fine. So these are the important point. Yeah, and one more point I think I forget. Yeah, in this one level indicator controller is there. See, LI is there, LIT is there, LG is there, level glass is there, then LIT is there, and level indicator. In the absorber level, say flash drum or surrogate angle level is maintaining here, and here also tripping condition is there. See, LI and LT is there, and shutdown logic is there, and LI in the DCS we can see that this one. See, this is the shutdown logic. Just two symbols, legend is showing. That's all about P&I reading. I request you to read the P&I in proper way, and please contact me if you have any particular doubt on any of the information. So quickly I will go through the some of the information. That is a safeguard. Already we discussed the safeguards. In absorber, temperature, pressure level is very, very important. In the reboiler, it is a temperature and pressure. Also the level of reboiler, glycol level in the reboiler also important, that we discuss. In general, instrument air pressure very important. If instrument air not sufficient pressure getting from instrument air, that will be creating a shutdown. Then PSVs are important. Level in the flash tank and accumulator important. SDVs are important. And this item we have discussed in our area classes, even though just I will go through it. Glycol dehydration troubleshooting, High dew point temperature, what are the troubleshooting issues? Check reboiler temperature, check stripping gas flow, check circulation rate, check operating condition, check for foaming. So wet inlet gas temperature, too low, increased glycol viscosity, foaming problems and increased glycol losses. Too high, too much water and pure dehydration. This is a wet gas inlet temperature in the absorber inlet. If it is too low, increase glycol viscosity, foaming problem and glycol losses. Too high, too much water, pure dehydration. When the pressure is increasing, free water will be increased. Temperature is increased, free water will be increased. And differential temperature. Low differential temperature can promote foaming. What is low temperature differential means? The inlet gas temperature and the inlet glycol temperature. That will be in the differential temperature. High differential temperature can cause increased glycol loss and higher dew point temperature. Another one is foaming, chemical foaming, solid, salt, inhibitors, alkaline glycol, mechanical foaming, gas velocity, excessive turbulence. Glycol loss in conductor, foaming, mist extractors, gas gauge or excessive velocity, gas surge or excessive velocity, leak and scrubber. Pucking and flashing, that is in stripping column, carryover of the hydrocarbon liquids coming into this one pure glycol is recorded here. We have to make our fast intensity aim is to make glycol purity maximum, that is above 99 point. That's why this heating condenser coil and it is entering here. So in this one, this is carryover of the hydrocarbon is inside. It will create decrease the glycol purity and excessive stripping gas. This one is the stripping gas for remove some improving the glycol purity. That is, if it is too much, then it will also reduce the decrease the glycol purity. High tower top temperature that I discussed in the previous slide. High reboiler temperature, that also the same problem. Damaged or fouled packing. This packing always have to any damage or fouled packing means damage choking coming. Leak or on heat tubes and our heating coil leakage. How to care glycol? Prevent oxidation. That is prevent temperature. High temperature glycol start to oxidation. Prevent thermal decomposition in a very high temperature. It will change the entire property, then we cannot use that glycol again. pH control, very important. Avoid salt contamination, very, very important. Avoid hydrocarbon carryover. Remove sludge, avoid foaming. And routine operator check, quickly we will go through that one. We have discussed in our almost in our 4 sessions. Still we can go through just to read it, that one. Check levels in each vessel. Check pressure, you have to read that one. Check the temperature, check the flow of glycol contactor, check the pressure of glycol gas vessel, flash vessel, check reboiler temperature and reset it, and level in the surge tank, check the water content and dew point of outlet gas, inlet gas flow rate, if it is changed, change the glycol flow rate, check the inlet gas temperature, check glycol pH and adjust. Yeah, thanks for watching this video. Almost I think glycol session is over now. And definitely we will go to in gas processing any other pending modules are there. I will check that one, or I will start our some other latest session from oil and gas operation. We have as we discussed in our previous class, we have advanced online classes are there. The details are here in 5 module: process, mechanical, instrument and electrical and safety. Course period is 5 months and details are here. Our practical oriented approach, case studies are there, homework, suitable timing and training materials, end of exams and certificate. Please contact me on my mobile, WhatsApp or Gmail for the course fee and other details, suitable timings, etc. So thanks for watching. Please subscribe this channel for updation and joining in my Telegram channel as usual I said. So definitely we will meet in our coming video. By the time, bye bye.